Right now, more than 2.5 million trucks cross the Brenner Pass every year. They funnel through one of the most important road corridors across the Alps. One pass, one bottleneck, roughly 1,371 meters above sea level. The Brenner Pass connects Austria and Italy. The railway across it was built in the 1860s and opened in 1867. The railway there is ancient, steep gradients, slow speeds, maximum loads that are small by modern freight standards. On the Italian side, heavy freight trains can require at least 2 locomotives just to climb it. On the Austrian side, at least 3. That is not an efficient modern freight corridor. That is a physical constraint on businesses shipping goods north or south through Europe. Here is the problem. The Brenner corridor is under enormous pressure from road freight. Every truck that crawls over that mountain adds cost, emissions, and time to the supply chain. Traffic restrictions are not merely theoretical. Austria's Tyrol province operates nighttime, sectoral, and winter truck bans, along with traffic dosing measures that restrict the number of heavy vehicles entering the corridor at certain times. Italy has challenged those measures before the European Union's Court of Justice. An overloaded transport corridor has become serious enough to create legal and political conflict between 2 EU member states. Now watch what they are actually building underneath it. The Brenner Base Tunnel itself runs roughly 55 kilometers between Innsbruck in Austria and Fortezza in Italy. When around 9 kilometers of the existing Innsbruck bypass or in-valley tunnel are included, trains will travel through a continuous underground rail connection of approximately 64 kilometers, planned to become the world's longest underground railway connection. Instead of a single conventional double-track bore, it consists of 2 parallel main tubes, each carrying 1 track, connected by cross passages. It is electrified and built for high-capacity European rail operations. Passenger trains are designed for speeds of up to 250 kilometers per hour. Freight services will use a route built around much gentler gradients than the existing mountain railway. And the route is nearly flat. That single fact changes everything. The existing Brenner Railway climbs steeply toward the pass. The base tunnel's gradient is only about 4 to 7 per mile, with its highest point roughly 580 meters below the Brenner Pass. That dramatically reduces the traction challenge for freight trains. Less climbing means less need for additional locomotives. Less locomotive assistance means longer and heavier freight trains become easier and more economical to operate. More freight per train means rail becomes significantly more competitive against road haulage on the corridor. The math is not subtle. The rail journey between Fortezza and Innsbruck is expected to fall from roughly 80 minutes today to around 25 minutes once the new route is operational. That is not a marginal improvement. That is a fundamentally different transport product, and construction is now deep into its final excavation phase. 9 tunnel boring machines have been deployed over the course of the project. By July 2026, both future main railway tubes had achieved cross-border breakthroughs between Austria and Italy. As of August 2026, TBM Wilma was completing its final meters on the western tube, while Olga continued excavating the last section of the eastern main tube toward Innsbruck. Once Olga finishes, excavation of the 2 main railway tubes will be complete. By August 2025, 88% of total tunnel excavation had already been completed, and excavation on the Italian side was finished that year. The tunnel is scheduled to become operational in 2032. The European Union has backed it heavily. EU support planned through the end of 2025 totaled roughly 2.3 billion euros. Spanning earlier TEN-T funding and later Connecting Europe Facility transport grants for the base tunnel and related access works. This is not simply a regional project. It is the central Alpine link on the Scandinavian-Mediterranean corridor, one of Europe's major north-south transport axes, stretching from Scandinavia through Germany and Austria, across Italy, and onward toward Malta. One tunnel, one mountain, one critical node in the spine of an entire continent's freight network. The trucking industry is watching this closely. They should be. Europe has seen part of this story before. June 1st, 2016. Switzerland inaugurated the Gotthard Base Tunnel, 57 kilometers, maximum rock overburden of roughly 2,300 meters. Around 17 years of main construction work, approximately 12.2 billion Swiss francs. The tunnel entered regular service in December 2016. Today, up to 260 freight trains per day can operate through it. The Gotthard is a base tunnel. That means flatter gradients, longer trains, heavier trains, more efficient freight movement through the Alps. But there is an important distinction. Switzerland's shift of Alpine freight from road to rail was not caused by the Gotthard Tunnel alone. It was the result of an entire transport strategy. Switzerland combined its new base tunnels with heavy vehicle road charges, railway market reforms, operating support, upgraded freight corridors, and an explicit national policy of moving trans-Alpine freight from road to rail. Today, roughly 3/4 of freight crossing the Swiss Alps moves by rail. That makes Gotthard important as a precedent, not because one tunnel magically removed trucks from the road, but because it demonstrates what becomes possible when flat, high-capacity railway infrastructure is combined with policies designed to make rail competitive. That is the more realistic blueprint for the Brenner. And here is where the scale becomes significant. The Brenner corridor currently handles roughly 50 million tons of goods per year, alongside more than 2.5 million trucks. A significant share of that freight currently moves by road. When the base tunnel opens, rail is expected to become substantially more competitive for high-volume, long-distance freight moving along the corridor. Faster rail transit, lower gradients, longer and heavier trains, electric traction, less exposure to road congestion and some of the restrictions imposed on heavy trucks through Tyrol. For standardized freight moving between major logistics hubs north and south of the Alps, the economic case for rail should become considerably stronger. That is the disruption vector for trucking. It is not that trucks disappear. They do not. Last-mile delivery still requires road transport. Specialized cargo, temperature-controlled loads, time-critical shipments, and freight with complex origins and destinations will continue to depend heavily on trucks. And even rail freight frequently needs trucks at both ends of the journey. But the high-volume point-to-point freight that currently moves long distances over the Brenner by road, that segment will face a much stronger rail competitor than it does today. A single freight train can replace dozens of truck movements, depending on its length, loading configuration, and cargo. The Brenner Base Tunnel does not automatically guarantee that freight moves from road to rail, but it removes one of the physical limitations that has historically weakened rail on this corridor. That matters enormously. The employment picture is therefore significant too, although the precise effect cannot yet be known. If substantial long-distance freight shifts to rail, companies specializing in Alpine transit trucking could require fewer trucks and drivers for some long-haul routes. At the same time, intermodal rail freight can generate more demand for shorter first and last-mile truck movements around terminals and logistics hubs. So, trucking does not disappear. Its role changes. Some businesses built around heavy-through traffic across the pass, fuel stations, rest facilities, and road service operations, could see lower demand if road freight volumes decline significantly. But the extent of that effect will depend on how much total freight demand grows and how rapidly companies actually shift cargo onto rail. Then there is the environmental pressure. The Alps are an environmentally sensitive region. More than 2.5 million trucks crossing the Brenner each year create substantial noise, congestion, and local air pollution pressures. European transport policy increasingly favors moving appropriate long-distance freight from road to rail. Shifting freight from diesel trucks to electrified rail can substantially reduce local tailpipe pollution and, depending on the electricity mix and operating conditions, typically lowers greenhouse gas emissions per ton kilometer as well. The political momentum behind rail freight is therefore not weakening. It is built directly into European transport policy. That does not mean regulators are trying to eliminate trucking. It means they are actively trying to move a larger share of long-distance freight onto rail, where rail can handle it efficiently. Trucking companies that depend heavily on Alpine transit, therefore, face a future in which the infrastructure itself increasingly favors intermodal and rail-based logistics. Switzerland shows what that kind of transport system can eventually look like. But it also shows something important. Infrastructure alone is not enough. Rail capacity, road pricing, terminal infrastructure, train path availability, access routes, regulation, and logistics economics all determine whether freight actually shifts. The Brenner Base Tunnel removes one of the largest physical barriers. What happens afterward will depend on how the rest of the system responds. Meanwhile, construction underneath the Alps remains an extraordinary engineering operation. The tunnel alignment crosses geological formations whose characteristics change throughout the mountain. Depending on the geological and geotechnical conditions, engineers have used both tunnel boring machines and conventional drill and blast excavation. Support systems are adapted as excavation progresses. Rock bolts, shotcrete, steel supports, precast concrete segment linings in TBM-driven sections. Different stretches of mountain demand different solutions, and the project is now approaching a decisive stage. The target is 2032. When the tunnel enters service, roughly 55 kilometers of new low-gradient railway, forming part of a 64-kilometer continuous underground rail connection, will run beneath the Alps between Austria and Italy. It will be capable of carrying freight volumes that would otherwise require enormous numbers of individual road vehicles. The trucks will still be on the road above, but if the tunnel and its connecting rail network deliver the modal shift planners intend, there should be fewer long-distance freight trucks using that corridor than there otherwise would have been. The ones that remain will increasingly focus on the things road transport does best: flexible routing, first and last mile delivery, specialized cargo, time-sensitive freight. The corridor that has shaped Alpine trucking for generations will not suddenly belong exclusively to rail. But for the first time, the railway underneath it will no longer suffer from the mountain's biggest disadvantage, and that changes the competition.